Alright, so welcome back to the main Zoom room. And in looking at these warm-up questions, and guys, I was going around the room listening in, seeing many cameras on, microphones on. Thank you to those of you that are following expectations. You're going to get out of this course what you put into it, and participating fully is important. So in this first problem, I heard you guys say that we needed a common denominator. And our common denominator here, we do want to choose our least common denominator, which would be 8. So this denominator is already 8. So this guy's not going to change at all. And then our 1/4, we're going to multiply by 2 over 2 to get 2/8. An equivalent form, but equal. Because what we're really doing here is just multiplying by some form of 1. And so then you'll do 7/8 minus 2/8. Your denominator stays the same. You operate on the numerators and get 5/8. Now, this second question also required a common denominator, but this time neither one of these numbers is the common denominator, right? So you see the difference between these two problems? Here, 8 was the common denominator, but here we needed an entirely new number to be the common denominator. The numbers 3 and 4 are called relatively prime. 4 is not a prime number, but 3 and 4 are relatively prime. That means they're prime in relation to each other. They have no other common factors besides 1. So when that's the case, you need a brand new denominator, and that denominator is actually going to be the product of the two existing denominators. So this first fraction is going to need to be multiplied by 4 over 4 to give us 8/12. And our second fraction is going to need to be multiplied by 3 over 3 to give us 3/12. And then you're going to subtract and get 5/12. All right, problem 3 asked you to factor. And key here is that each one of these is a perfect square. So you're going to factor this into this is the difference of two squares. You're going to have x plus 4 times x minus 4. So hopefully you remember that from your lessons on factoring back in Algebra 1, Algebra 2. Now this problem also says factor, but this is a different type of factoring. Here we're going to factor out the greatest common factor, which is a 2. So we're going to factor the 2 out and be left with x minus 8. Okay? So factoring here, difference of two squares. Factoring out here, factoring out a common factor. All right, all of these skills are going to be related to our lesson on simplifying trig expressions. Kind of keep those in your mind. Pay attention to where they crop up. So now we're going to move into our pre-cal lesson. Today we are looking at simplifying trig expressions. So we're not going to have any equations here. We're going to take an expression and we are going to simplify it. So often it's hard to know when we have actually simplified. So our goal when we're simplifying a trig expression, a very broad and general goal, is going to be the least terms possible. So if we can get it down to a single thing, like the number 1 or cosine theta, that would be simplified. It might not go that far. It might go down to something like 1 plus cosine theta. But we want to get it down to the least number of terms possible. Now, these are like little puzzles that you have to figure out. And you know how sometimes you're putting a puzzle together and you think this piece goes here and you try it, but then it doesn't, and you try another piece. It's kind of like that. So there are some strategies that I can recommend to you, but this is not a this is a list of strategies to pick and choose from. This is not like step 1 do this, step 2 do that. This is just a list of strategies. So factor, and if you can, factor first, if that's possible. When you see that some things are squared, you want your brain to think about the Pythagorean identities. And then as you're simplifying, if you take whatever stuff you have and try and write things in terms of sine or cosine, that is going to move you towards simplifying your trig expressions. Okay, so these are our strategies. All right, before we get into our first example, I also want us to take a look at the Pythagorean identity. So if you take your formula chart, okay, last time we were together we focused on these reciprocal identities. And then this next row going across we have the Pythagorean identities, and you see that we have 3 of them. We're mainly going to focus on this first one. But I want to show you how this first identity can be transformed, and we can actually, out of this one identity, there are really 3 identities. So this identity says sine squared theta added with cosine squared theta is equal to 1. We looked at the fact this is coming from your unit circle. But if I wanted to solve this equation in terms of sine, if I wanted to get sine by itself and I subtracted cosine squared theta from both sides, I would get this identity. Sine squared theta is equal to 1 minus cosine squared theta. You see, all I did was subtract cosine squared theta from each side. So this is an identity. It's true for all values of theta. This is an identity. It's true for all values of theta. All right, likewise, I could go back up to the top one, and I could solve for cosine squared theta. So that would mean I'm going to subtract a sine theta from both sides. So that would be 1 minus sine squared theta. So this is another identity. It's just in a different format. All right, so now we're going to solve some problems together. Now, as we simplify these trig expressions, there is more than one way to get to the answer. So the way that I do it is not the only way. You may think of another way and know that that is just fine. Just like if we were here in my classroom, room 223, and you were going to go down to the library, some of you might take one staircase and walk across the hall. The others of you might walk across the hall and then go down the staircase, right? We're still starting here. We'll still end at the library, but the route we take could be different. Same thing with simplifying these trig expressions. All right. So we take a look at this one. Soren, you with me? Yes. And we look at our strategies. Do you see anything that can factor out? I don't see any common factors, no difference of 2 squares. Do we see any squares? No, no squares. So let's just rewrite things in terms of sine and cosine. So we've got my cosecant theta. You go to your reciprocal identity. Cosecant theta is 1 over sine theta. So I'm going to take cosecant theta and I'm going to rewrite it as 1 over sine theta. Just doing a substitution. All right, then secant theta, well, same thing if I go to my reciprocal identities. Secant theta is 1 over cosine theta. These guys are being multiplied together, right? Now then I've got to do cotangent of theta. So with my reciprocals, cotangent is 1 over tangent, but that's not really going to help me get down to sine and cosine. Like, I could do that, but it's going to be a longer route. I'm going to go over here to my quotient identity that says cotangent theta is cosine over sine. Now I've got everything in terms of sine or cosine. So the first thing I'm going to do is multiply these two fractions together. Multiplying fractions, that's no problem. Top times top. Bottom times bottom. Just going to express that as sine theta, cosine theta. Minus, and I'm going to bring this fraction down exactly as is. So look at what we have here. We are subtracting fractions. So what you should know, and you were reminded about in the warm-up, is when you subtract fractions, you have to have a common denominator. Can you see that sine theta times cosine theta would be your common denominator? Sine theta is a factor of sine theta cosine theta. Just like in our example, 4 was a factor of 8. So we're going to leave this fraction alone, and we're going to multiply this fraction. Oh, I forgot my little theta there. We're going to multiply this fraction by cosine theta over cosine theta. Right. What are we doing here? We're getting a common denominator. So remember, when you just did your fraction problems, once you have the common denominator, your denominator stays the same. Sine theta, cosine theta. And we'll go ahead and operate with the numerators. That would be 1 minus cosine theta multiplied by cosine theta will be cosine squared theta. All right, now, look at 1 minus cosine squared theta. You've got a square. When you have a square, think about your Pythagorean identities. Look up here to your Pythagorean identity, line 2. Oh, do you see that 1 minus cosine squared theta is actually equivalent to sine squared theta? So we're taking this guy right here and we're going to substitute it in. So that's going to be sine squared theta over sine theta times cosine theta. Well, think about what sine theta means. It means sine theta times another sine theta. That's divided by sine theta over cosine theta. Notice we have multiplication going on here. So if everything in the numerator and everything in the denominator is being multiplied, we can divide out our common factors. So sine theta divided by sine theta is 1. So then I'm left with sine theta over cosine theta. Oh, but what is sine over cosine? Look at your quotient identity. Sine over cosine is just tangent. So all of this mess is just equal to tangent theta. Woohoo! We did it. We simplified the trig expression. Are you having fun yet? No? This is the best, y'all. Alright, let's do another one. Each one of these is unique, right? There's not really a formulaic way we can do it, but we can look at our strategies. Alright, so question 2 says, secant x minus the tangent of x times the sine of x. So Some resources are going to use theta for your angle measures. Others might use x. I'm going to switch back and forth so that you're kind of comfortable with each one. So again, as we look at this, we would say, anything we can factor out? Nope. Any squares? Nope. All right, well, let's turn things into sine and cosine. So secant theta, reciprocal formula. Secant theta is 1 over cosine. So this would be 1 over cosine x. Tangent, we want to use that quotient identity. Tangent of theta is sine over cosine. So we'll have sine x over cosine x. And then we're going to multiply that by sine x. And if it helps you to see that that is a fraction, you can put it over 1. So I'm just going to go ahead and multiply this second part here. Sine x times sine x is sine squared x. Cosine x times 1 is cosine x. So I am looking at having to subtract fractions. So I need a common denominator, but woohoo, there's already a common denominator. So that's going to be 1 minus sine squared x over cosine x. So when you see a squared, think about your Pythagorean identity. Right? So remember we had here, we took our Pythagorean identity, we transformed it into 2 other forms. 1 minus sine squared theta was just cosine squared theta. So 1 minus sine squared x is just going to be cosine squared x. Cosine squared x means cosine x times another cosine x, and then that's being divided by a cosine x. Notice you got multiplication there. So when you're multiplying, you can divide your common factors. Cosine divided by cosine is 1, and so this simplifies down to cosine of x. Woohoo! We are done! Isn't it fun, y'all? It makes me happy. It's like a little puzzle. We figured it out. Alright, let's look at another one. Secant squared x minus cosine squared x secant squared x. Now at first you might be looking at all those squares and be thinking, oh, Pythagorean, Pythagorean, but slow down. Remember, it said if you can factor, factor when? Factor first. Do you see something we can factor out? You see it, right? Yes? What do these have in common? What do they both have? They both have a secant squared, right? That's a common factor. We're going to factor that guy out. The same way you factored out that 2 in the problem 4 of the warm-up. Alright, so just a little reminder here, because I know sometimes this just looks like alphabet soup to some of you. But remember in the warm-up, we had 2x minus 16, and you guys all knew you were supposed to factor out the 2 and get x minus 8, because the 2 was the common factor. Well, that's what we're doing here. Secant squared x is our common factor. We're factoring it out. Factoring out, you're actually dividing. Secant squared x divided by secant squared x is 1. Cosine squared x times secant squared x divided by secant squared x is cosine squared x. If you doubt yourself a little bit on factoring, go back and distribute this guy and see if it comes out to where you started. It's a way to check yourself. Alright, so there we go. We factored. That's nice. Okay, but now we've got some squares. When you see squares, think of the Pythagorean theorem, right? Pythagorean identities. So we got a few. So we've got a Pythagorean identity with secant, but you see if I replace that with tangent squared theta plus 1, I'm making myself have even more terms. I could do that, but that's like taking the long way there. I'm going to leave the secant squared for a minute, but look at this other one, 1 minus cosine squared. Do you remember your Pythagorean identity that we simplified? 1 minus cosine squared x is just sine squared x. So to go from here to here, this was the Pythagorean identity. Now, secant squared x. So here's something about your reciprocal functions. If I have secant squared equals 1 over cosine, or secant theta equals 1 over cosine theta, well, what happens if I square both sides, right? If I square this side, it'll be secant squared theta. And if I square this side, it'll be 1 squared. 1 times 1 is still 1 over cosine squared theta. So secant squared theta is the same as 1 over cosine squared theta. So this guy right here is 1 over cosine squared theta, cosine squared x. And how did we get that? That was from our reciprocal function. Reciprocal identity. Sorry, not function, it's an identity. If it helps you to have a little 1 there to see your fractions lined up, multiplying fractions, that's no problem. Top times top, bottom times bottom. Oh, but wait, sine over cosine. Sine over cosine is tangent. So sine squared over cosine squared is just tangent squared x. Woohoo! Y'all do not seem as excited as I am. I don't know what is wrong with y'all. This is so much fun.
I love this. This is great.
Yes, thank you. Whether you really do or not, somebody needed to say that, so I appreciate it. All right, number 4. This is going to be the last one we do together, guys. No, I lied. I think we're going to do one more together. Cosine squared x over 1 plus sine x. So we're looking at this guy and we say, well, factor. Can we factor? Can we factor? Not seeing anything that can factor. Oh, there's a squared. When I see squareds, I think about Pythagorean identity. Well, honestly, when I look at it, I don't see how that's going to help me, but everything else is already in terms of cosine and sine, so what else am I going to do? So I guess I'll go ahead and do that Pythagorean identity, right? Cosine squared x is 1 minus sine squared x. Now, for some of you, when you took geometry, remember you did proofs? Like, I'm not going to make you do this, but if some of you, if it helps your thinking, helps you to follow, you could kind of think of this as a proof, right? This was given. And how did we do this? This was the Pythagorean identity. So, what was it that we did here? We took this cosine squared x and changed it into 1 minus sine squared x by the Pythagorean identity. Everything else stayed the same. So if it kind of helps you to think in a 2-column proof and see what you're doing, that some people like to do it that way, Now you get to this point, and this is a point where you might be feeling a little bit stuck, and you say, well, all right, let me go back to my list of strategies. Pythagorean theorem, but we'll already use the Pythagorean theorem, so what good is it going to do it again? I mean, if I do the Pythagorean theorem, I'd just be changing that back to that answer. Now that I changed it, can I factor?
That has a square.
It's got a square. So you can factor the numerator. Are you seeing it with that hint? Hint number 2. 1 times 1 is 1 squared. Is this a perfect square?
Yes.
Is this a perfect square? How are you going to factor it?
Difference of 2 squares.
So, remember when you had x squared minus 16? And you did x plus 4, x minus 4? So now if I've got 1 minus sine squared x, that'd be 1 plus sine x and 1 minus sine x. Making the connection. See why we did that in the warm-up? Now, this is all multiplication, so when you're multiplying, look at this as an entire term, and you can take 1 plus sine x and divide it by 1 plus sine x. And this divided by this is 1. And so now you're down to 1 minus sine x. And that's as far as you can go. So remember I said we try to get down to one term if we can, but sometimes it's more than one term. All right. So your assignment is, there is a worksheet, and if you're a remote learner, it's a PDF loaded on Canvas, and it has 16 of these, and your homework is to do all 16, but you're going to turn one of them into a flip grid, and I'll tell you which one in just a minute.